Hello and welcome. We are going to, in this video, go over the very basics of CAD modeling. We're going to make a pencil. Okay. The idea is to go through most, if not all, of the features that you're going to need to use for the Machine Shop Lab class, or at least at the very, very minimum. So yeah, let's get started and we'll go for it, and we will make a pencil. All right. Let me just make my own screen my face a little smaller. There we go. Okay, so start out, we are in the program. So I've started a new part here. And before you do anything, there are already three planes. Okay, and it's usually a good idea to start a sketch on one of them. Okay, so we're going to start a sketch on the front plane. Okay. We're going to start the sketch by clicking that sketch icon that you get when you hover over things. Okay, so now we could decide what exactly we want to do first and how we want this to look. Okay, so what might be pretty obvious is to do kind of the easiest CAD feature first, and that's a very simple extrusion. Okay, so you have a cut extrusion or a boss extrusion. A boss is like kind of extending something in one direction. Hopefully, a lot of you will have intro an introductory course that goes over CAD modeling, but this may or may not be your first time hearing about it, depending on whether you're a transfer. So a lot of this will be kind of slow and boring, but hopefully we'll get into some things that you may or may not have been aware of. And we'll also try and go through some stuff that is not specifically on a pencil, like sweeps and holes as well. But I'm getting off topic. We're in this sketch, and now we're going to be tasked with drawing the profile of the pencil. So the main part that's like in between my hands right here. Okay. So first thing I'm going to do is figure out what shape that is. Okay, a hexagon, as you might have guessed. So now what we're going to do is we're going to measure the distance across the hexagon. Okay, I will hold that steady where it is on my caliper. So I'm using a pair of vernier calipers, sorry, dial calipers that give both inches and millimeters, hence the two hands. Okay. So what I got here is 0.274 and a bit. It looks like a little bit more than 0.274 inches, which is let's see, that would be 6.98 millimeters. Okay. So yeah, helpful to have a pair of calipers like this so you could get both units. Dial calipers are usually kind of better in some ways, kind of more difficult to read than digital ones, but largely more accurate. I'll go over measuring tools in another video. But anyways, I'm going to now do my best to draw a hexagon, okay, and give it that dimension. Okay, obviously that's what I'm going to do. Now, what might not be so obvious is the way to draw a hexagon. I can do something like, make lines like this, I'm sure, and draw somewhat of a hexagon. Maybe I can even, make um, all these lines of the same length. And, it would probably make itself into a hexagon. I'd have to constrain it with some angles and stuff like that. But this is kind of like the noob way to do it. You really don't want to make any shape like this. Well, very rarely do you want to do that. Sometimes it's hard to get your ideas on paper, so it's just helpful to start writing lines. But there are better ways to make specific shapes if you need to. So I'm going to delete all that. That is not the way we're going to do it. From the drop down here, you have like the ability to make these polygons. Okay, so I'm going to go here and, oh, cool, it's already selected a six-sided polygon for me. I'm going to click the center point here. Okay, so I can indeed start this polygon anywhere I want to. Okay, but I would definitely want to start it in the middle here. Okay, I want to start it in the middle there because that is the origin. All right, and what it will eventually mean is we don't have to do so many things to the sketch in order to constrain it. All right. So what I'm also going to do here is bring this line horizontal. Okay. And you can see I have, you can't see where my finger is pointing, but you can see right next to that pencil icon, there is that horizontal line. Okay. Or that white box with the black horizontal line in it. That is, indicating that we are going to be horizontal, okay? And it's a constraint that allows us to make sure that we are not are like sort of totally fixed and what they call in SOLIDWORKS fully defined. Okay, so right now I have declared that be horizontal, okay? And I'm also going to declare the dimension. Okay, so like I said before, the dimension is 0.2 74, we'll call it. 0.274. 0.274. All right. And I'm in inches now. I'm a redneck. I usually am more comfortable in inches, although it's very easy to toggle back and forth between units. Yeah, I guess I should talk about that really quick. The way you do that is down here. This is how you change units, and there's a lot of other things that you might need to change as well. But anyways, we've defined our hexagon. Okay, and we've given it a dimension, but we're still blue. Okay, so I guess apparently, even though you go horizontally, you need to make a relation on this that makes that one horizontal. Okay, and now you could see this shape is now fully black. Okay, so that means it is fully defined. Now, this shape that's like hovering out in space doesn't have a defined size and it doesn't have a defined orientation and it doesn't have a defined location. Okay, and that's what the horizontal relation did there. And that's what starting it at the origin did and finally adding the dimension. Okay. So cool. So we've done what we needed to do. Okay. And yeah, I guess that's all we really need for this particular part of the shape. So anyways, I'm going to highlight this. I'm going to delete it. All right. And then I'm going to extrude this shape right here. All right. So let's extrude it. Well, let's first exit the sketch. This is a fully defined sketch. That's all we need right there. Now I'm going to extrude this shape, and to do that, I'm going to go to the extrude boss base. Okay, and I'm going to make it the length that I see the yellow portion of my pencil. So I could probably make this a little bit bigger. Do. Okay, and I will put it up there so you can see it. Okay, so let's see what this is. We're just going to go pretty generally. Hopefully I can go. It's less than 6 inches. It is. Excellent. Okay. So we're going to basically call that like where the yellow starts. And I'm going to be kind of rough with this because I could have sharpened this more or less. But we're going to call that 5.925 inches. Okay. So let's just do that. 5.925. Whatever. Okay, cool. So now I've made the middle portion and let's make my face a little smaller again. I made the middle portion. Okay. Now I need to make the other portions. And now let's do the eraser part. Okay, so first thing I'm going to do, so that was a boss extrusion. Okay, and you'll see in the presentation that you could do that sort of action and also make a cut, or you could do a boss extrusion like I just did. We're going to do next, we're going to do a revolved boss base. Okay, so to do that, first I'm going to locate the plane that goes down the middle. Okay, I like that one. So that one starts out where it intersects where that like sort of corner is, that edge that goes along there. And that's good. So we're going to sketch on that one. So that would be the top plane, and we're going to sketch there. Okay. Now, what I'm going to do is attempt to make a pattern that I can revolve to make this to make this part. Okay. So first thing I'm going to do is I'm going to grab the center line. I'm going to go up from, whoops, I missed the origin. Let's try that again. So I'm going to go up from the origin. I'm going to make this a construction line. So there we go. All right. Now we are going to make this a construction line. So for construction. So this is the edge that we're going to revolve everything around. Okay. So now let's go about making just generally what this thing looks like. Okay. So it looks like, yeah, it looks like there are little tiny holes that we're going to ignore. And we're going to focus on the overall sort of shape of everything. But let's just focus on like the eraser as a whole. I'm going to pretend my eraser is not worn down. So yeah, first thing I guess we can do is let's get the overall length of this thing. Okay. So the overall length there, I'm gonna call that 0.720. Okay, so let's dimension that. So 0.72 inches. Okay. Okay, so after we draw the length here, we're gonna start to draw the shape of the eraser. Now it's kind of finicky to measure this, but I'm just gonna kind of make what looks aesthetically correct because it's not like gonna be an exact thing. Like I'm not gonna have something that I could like visualize the exact shape of this. So I'm just gonna go ahead and make these like little hemispheres here. Oh, not like that. So I'm making these by like sort of, you know, bringing the cursor away from that point and then back to it, and then it can allow you to do these sort of arc things. And it looks like on the pencil here, I'm seeing that there's like three little arcs on the bottom, and then three little guys on the top as well. Okay, so come on. Now that we have all those roughly drawn, okay, so there are those six of them. Let's make all of the arcs equal. So come on, let me click you. So I'm shift clicking all these arcs. Okay, shift clicking them. Okay, cool. And we're gonna make all of these guys, all six of them equal. Okay, cool. And let's put a dimension on them. We're gonna make them, yep, zero point 0.2, or sorry, 0.02. There we go. And what I'm gonna do also is so if you look here, there's like kind of a pattern. There are like these three little bumps, and then there are these like sort of vertical ridges, and then there's another three little bumps. So I'm trying to detail those right now. So let's make the middle ones equal. Yep, so all of these. Okay, we're gonna make those equal. And we're gonna set actually, let's make these two equal, the top one and the bottom one, because I think there should be symmetry, or at least, it'll look good if there's symmetry. Uh-oh, we've angered it. Let's go back, Control Z, and let's dimension this 0.1, and then we're gonna make this 0.05. Okay, cool. So now we have everything fully defined. So yeah, that looked like a lot of complication and a lot of stuff that like I did. And indeed, there are a lot of relations, and I could go up here and I could show all the relations that we have. Sorry, I gotta click off of that entity. So if I show all the relations, you can see all of these guys are all the relations on the left-hand side over here. Um, and that's what makes all of this like fully defined, and there are only one, two, three, four dimensions really. But because like it's related to like a lot of these other parts, it makes it, yeah, it makes it fully defined. So cool. So now what we're going to do with this is we're going to revolve it. So we're going to make it like a cylindrical shape. So okay, so let's hit check on that. We're going to exit the sketch. We're going to do a revolve. Sketch is currently open. Okay, it's going to close it. Good. That's fine. Okay, cool. So it's doing that revolve. So if you were a little bit confused as to what I was doing before, like that's really it. It doesn't, do anything particularly mind-blowing, but it might be hard to visualize it if I'm just telling you what revolve is rather than showing you. So that's what it'll do. I could also probably revolve it about a different axis. So let's see what it, just for curiosity's sake, let's see what it looks like here. Whoa. So you see that? That's a weird axis to put it around. But anyways, there are lots of possibilities with that. You just basically need an axis or like a straight line and a a curve to wrap around it, and that's it. So anyways, clicking that revolve, nice. Now what I'm gonna do is yeah, let's start to make this. Actually, you know what? I slightly did that wrong. Um we need to add the eraser as well, which means we need to make the overall length of this a little shorter. So let's go back. Sorry. I've totally forgot to add the stinking eraser. That was silly. Okay, we're gonna make this instead of 0.72, we're gonna change it to point 0.5. Okay, cool. And we're gonna make this 0.07. And we're going to make this 0.02, and that should magically solve it. And it looks like it did. Okay, cool. So hopefully that, yep, goes back. Cool. So we'll call that, a relatively co close version of that. It doesn't have the vertical parts, but yeah, anyways, that's good enough for a revolve tutorial. And now we'll really quickly just sketch on here and let's make our eraser. So, in addition to making cylindrical things with the revolve, you could also just do it straight up with an extrusion. So I could quickly show you how you might do that, and I'll show you how to use the fillet tool because that's like also sort of a method too. But anyways, we can make that guy there. Let's see if I can figure out the diameter of the eraser. It's going to be a little bit smaller than that of the metal that goes around it. So this is going to be 0.258. Okay. 0.258. Okay. And then we're going to extrude this. Actually, I don't like that. I want to just do it by the wall thickness there. And I'm just gonna judge very generally what the metal thickness is there because it's kind of a little bit of an irregular shape because it's all like, bent a little bit. So we're gonna make this 0.05, 5 thou. Oh, sorry, that's 50 thou. I need to do 5 thou, 0.005. Okay, cool. Now we're gonna extrude a boss base, and I'm just gonna make this, um, let's grab our sketch. We're gonna make this 0.25. Okay, cool. And just so that it looks a little bit more natural, we're going to, that actually looks a little bit long. Let's make it 0.23 and 0.2. Let's rebuild so that we can actually see it. Yeah, that looks a lot better. And now let's add a quick little fillet around the other side. So I'm going to go use the fillet tool that's up here. And then I'll click the edge. Okay. And 0.05. Okay, cool. That looks good. All right. Nice. So that looks pretty natural there. Now, you might be saying this doesn't look very good in terms of like accuracy. It's not the right colors. Okay. Well, so what we're going to do is change that now. So I'm going to actually do that by virtue of like what I've set up here. So yeah, good reason to do the revolve separate from the eraser is so that I can, click them individually and make that like feature a certain color. So with this boss extrude, I'm going to go to the appearances. I'm going to change the boss extrusion, and we're going to make it, yeah, just kind of a yellow. If you really want it to be accurate, you can use this guy, which allows you to like probe so I could, make it what color my skin. That's kind of cool. It picked up on the little zoom screen. So that's what color it thinks my skin is right now. My shirt color. There you go. But we're gonna use, yeah, that looks like a fine yellow. That, pretty close. Of all the like palette colors, I'm not gonna mess with it any further. So that's good. Now this one here, let's mess with the revolve. So I'm going to change appearances to the revolve, and we're going to make that really, I mean, gray is probably fine. But what I can do, what's like a silver? I can probably use this. Hold on. This might be kind of clever, but can I hold this up and use the dropper? That looks a little green. Okay, so let's try that again. Eh, do I like that? Let's click check. Whatever. It looks a little bit bluish, but you get the idea. And then the other one should be easy. That'll be a pink. So let's make this change this appearance to appearances, do that boss extrude. And we're just gonna use the pink, maybe not that pink. And also the fillet. I guess we got to do that individually. Fillet. And we're also going to make that pink. Well, same pink. There you go. Cool. So, yep, now we have more or less the colors that are used. So now we're sort of missing what is happening on the tip here. Okay. So let's do that. Now we're going to do that in a slightly different way. Um, so let's get started on how we might do that. So this is going to be a loft. So a loft is when you have two fully enclosed sketches and you're going to link the two of them. Okay. So really it's going to be very simple. This is going to be the dead simplest version of a loft that you could have. It's going to be a point on one side and then it's going to be a closed sketch on the other. Okay. And we'll play around with it a little bit to show you sort of other functionalities of it that are, not just for making cones. Okay. But that is what we're going to do now. So let's go ahead and sketch on this surface. Okay, we're going to make a circle that goes from there to there. Okay. Yeah, and I know you're probably thinking, it's not gonna, why are you making that bigger than like the hexagonal shape? You'll see what I end up doing, and it kind of works pretty well with the effect. So that's all we're gonna really need to do there. I'll show you that is fully defined since we started in the origin and went to the edge there. You can see literally with just those two relations, the coincident at the origin and the coincident at the outside, it makes it fully defined, okay? Which is again important for your grades. Next, let's make another plane that is a certain distance from that one. So we're going to go to up here to reference geometry, and we're going to go to plane, okay? And we're going to set this plane offset from that surface up to this is roughly, yeah, we'll go 0.75. Should be fine. 0.75. Oh, sorry, I'm not in the correct box. There we go. 0.75. There we go. Cool. Now we're again going to sketch on this plane, and we're very simply going to just put a point. Okay, and we're going to again line it up with our origin. Cool. So there we go. Now let's do what we do with a loft and merge these two shapes with like a lofted, sort of boundary. So here we go. So let's go to lofted boss base. It's already selected the last sketch I did, sketch 7, which is the point. Now, if we go there, you could see, voila, we've made a pencil point. Okay. But, to show you really quick other things that you can do, I can make guide curves as well. So I'm going to pick a plane that is sort of along, that is like orthogonal with the planes of both of those sketches. Does it have to be orthogonal? No, but I know that if it's orthogonal with both of those planes of those sketches, then I can link those two together. The planes can be at an angle, but really, as long as they intersect, then I know that I can connect my guide curves with my profile sketches. So again, the very simplest loft is just two of these shapes. They're called profile sketches, but I could link them together with other open figures that can sort of morph their shape. So I could go here. Now I'm sketching on this plane, and this is my circle that I had here, and this is the point. And let's make this extra funky. And I want to be coincident with the circle, and I want to go there. And this is a spline, so I can make it all sorts of wacky. Here we go. I can drag on these points, make it really, oops, come on. There we go. Make it all sorts of wacky. So you have to add a relation usually for the loft that makes it pierced. See how that kind of changed some things? Hopefully the point is okay with the coincident. I think the point will be okay. So let's change it and let's see if we can finally loft it. So we're gonna do sketch 6 to 7 using 8. Yeah, you see. Okay, cool. So we added that relation and it made it do it. And as you can see, it's sort of trying to follow the line of that curve and make a funky tip to it, as you can see. But we don't obviously need to use the guide curve, so we're going to take it out. That was just to sort of show you what it can be used for. Lofting is finicky. You will have to use it on your router part. But yeah, other than that, like there won't be a whole lot of uses for it in this class. Okay, so now what's happened is it looks like uh the circle is too big, and I mentioned this before that that would probably happen. So what I'm going to do now is actually go on and sketch on this surface, and this is going to be a really easy fix to that. That's going to make this look aesthetically quite nice. So as I'm on that surface, I need to basically make all of these little circles, or sorry, like semicircles, whatever you want to call it, like crescent, not really crescents. Anyways, these portions here I need to make into sketch lines. So I'm going to go to convert entities. Actually, let's do convert entities so that I could select all of this stuff at the same time. Do, 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 do. There we go. Okay, cool. Convert entities. Okay, great. So now I have all of those outlines selected or made. Now, while they're selected, let's do a cut extrude. So here's a cut extrude, and I'm gonna have it go. First of all, I have to define where I want it to cut. So yep, there, there. This is gonna look weird for a second, but hopefully it makes sense afterwards. So anyways, oh, one more. I've selected the sort of boundaries I want to be cut, and we'll let that go there. Aha. So it looks, yeah, it kind of looks just like a pencil tip as it's been shaved. There are other ways I could have done that. I could have, you know, cut the whole thing. But obviously I wanted to show you how to use a loft and, that's, maybe not that difficult of a way to do it. A little bit finicky, but, aesthetically looks just fine. Okay, cool. So now what I can do, let's do, you know what we can do? Let's create different bodies. Let's grab this plane. We're gonna make another plane from it. We're going to flip the offset. We're gonna do 0.25. Okay, cool. Click check on that. No, once we have this plane, we're going to do curves, split line. That one and that one. And we'll do intersection. And so, yep, that's that plane and that one. Oh no, why is it not doing that? There we go. Now it's selected it. Okay, cool. So it's doing that split line. Now, hopefully, yes, it allows us to select those in different at different times. So here we go. We'll do that face. Okay, and we'll make this wood colored. So sort of, let's see, sort of tan. Yeah, something like that. Sort of reddish tan. And then we're gonna make the other one pretty gray. So let's click check on that color. And then now we're gonna make the tip. Let's change that appearance, change the appearance of that face. And we can make that just, yeah, make that like more or less black. Cool. So now, yeah, as it appears, we have all of the things that we need for a halfway decent pencil. Okay, and we've used most of the tools. Okay, but notably, we have not used some of the tools that we use all the time. So right now, I'll sort of halfway ruin this pencil in putting some holes right through the middle, even though it doesn't have that, just to explain what sort of holes that there are. Okay, so usually when you do Hole Wizard, I could sketch on this face right here, and I'll use that origin as it stands there. So I'll sketch on here. I'm going to make a line that I'm going to end up putting a bunch of holes on. So usually, come on, usually if you have a hole, you will not, okay, um, use a cut extrude to make that hole. Normally, if you have a hole, you're going to use a hole wizard tool or something like that. So really quick, I'm just making this line on, a sketch, with a very simple line with four dots. Or sorry, with three dots. I'm going to explain three different sort of types of holes. So I'm going to make these all for construction, and they're all going to be equal. Okay. So yeah, let's click check on that. Let's dimension it. We can just give it a very simple dimension, zero point 0.5. Okay. And let's exit out of that guy. All right. So now we've made that sketch, kind of hard to see, but we've made that sketch. Yeah, there we go. And now what we can do is we can make holes that go along there. Okay. And I've chosen, I'm going to use these 3 points over here to make a tapped hole, countersinked hole, and like just like a through hole. Okay. So all right, here we go. So I think I have you guys using mostly num 832 screws. So an 832 screw, You could look up the specs, but what you could also do is use the whole wizard and it sort of gives you the specs. So what I can do here is I can go to the whole wizard. Okay. I'll select the type of hole I want. So there's lots of hole types. Come on, let's extend that. Come on, let me do it. There we go. So here we have some counterbore holes. All right, so let's explore that one first. It's the first one. So we have the size, that's a number 8. We're in anti-inch. There's also metric screws and a whole bunch of other ones. And we don't want the binding head screw usually. I give you guys a lot of the socket head cap screws, which are here. Okay. And we are going to use the number 8 and we're going to make this guy go through all, just for this example. So, actually, ooh, number 8 won't fit on this face. Let's go as small as we can. We'll use a number 2, and we'll use a socket head cap screw. It'll be the same sort of principle, but you guys are going to use 832s. This is going to need to be a different size. So let's go positions. We're going to position it on this face. Okay. Man, it's just barely too big. So we'll go to the number 1 size. Okay, cool. And there we go. There's our countersink hole. All right, I'm gonna go back to type here and change it back to a number 1. Okay, cool. And I could even go to 0 if I want. But number 1 works. It fits on the face. It explains what I want it to do, even though this is kind of a silly example. It just ties into the original part that, I wanted to make. Anyways, so this is your counterbore hole. I can get it to show custom sizing and it shows me what it's doing here. And yeah, as you can see, it's kind of handy in that it knows like a good clearance hole size for your number 1 screw or, whatever screw it might be. It's easy to know the clearance hole size if you have like a 1/4 inch screw because usually you just make it like a little bit bigger, usually around 10 to 15 thousandths or 5 to 15 thousandths rather larger. But if you have like a number 1 size, even I don't have the major diameter of a number 1 screw size memorized. Neither do I have the major diameter of a number 8 screw memorized. But if I use SolidWorks here, then I can use the tool to and use the preset ones, and it gives you good values, right off the bat. So I'll click check on this. So cool, there's our counterbore hole. I'll show you all the examples. So I'll do another hole wizard. So we'll keep it on a number 1, but we're going to go here and we're going to do the straight tap. So this is a tapped hole, one with a internal threading. And we are going to do the cosmetic thread, hopefully. Yep, cosmetic thread. So hopefully it shows it to us. And we're going to put it again on this face, but we're going to put it a little bit farther down from it. Okay, cool. So as you can see, the tapped hole is much smaller than the inner hole here. We're going to be tapping holes for mill training, but this is kind of a good example of like what is like sort of shown by a tapped hole. It gives you this dotted line, which is supposed to be sort of like the major diameter circle, I guess, and this is like sort of the minor diameter circle. But yeah, obviously, like this is a clearance hole, so the bolt that will screw into this hole will fit through there, without, having to even push it really hard. It'll just slide through very nicely. Okay. And yeah, I guess I could do another example here. I can also use Hole Wizard. I can do just a regular hole. Okay. You got to be a little bit careful here because if I go over here to the counterbore hole specifier, it gives me a type as a binding head screw, which I could change to socket head cap screw, which is the ones I'm going to give you. Okay. But if you go over here to this guy, to just the regular hole, okay, it changes to drill sizes. Okay. A number 1 drill is not necessarily good for a number 1, or it will not be good for a number 1 bolt size. Okay. So yeah, it's a 1/64. That means it's a 1 bolt size with a number with 64 threads per inch. That's what we specified with the tapped hole. This number 1 drill is like a gauge size, which are also kind of a weird sizing metric, but there's a difference between the number 1 drill size and the number 1 bolt size. I know, very confusing. And also, I should have mentioned this earlier, but with the tap size here, it allows you to show custom sizing. This is the tap drill size that it specifies, and that is like the standard one for the 164. And if I change that here, it would also change the tap drill size. So that's worth mentioning. But yeah, I'll also show you a counter bore. I could or sorry, a counter sink, which is like the conical one, which you could also do. I could order some of those, I guess, but normally we just do the counter bores. But I'll show you this just as an example. So we're going to click again on the surface and finally do that bore there. Okay, cool. And you'll see I'll also do a drawing. I'll do a detailed drawing video, and that'll show you exactly how to detail these holes and do hole call outs. And basically, the reason you do the hole wizard is so you have very specific hole call outs when it comes to making your drawing. Okay, if you do it with cut extrudes, which is totally possible, you will not have that hole call out, which will be a hindrance. Okay. So anyway, that will conclude this part of that will conclude this video on this pencil. Hopefully this will be helpful, and it shows you generally what you need to be doing for, I guess, all the parts. The only thing I didn't really touch on is the sweep, which I'll do in another video that shows you how to do the track.